Hello guys, my name is Craig and welcome to Peri Solutions. In today's video, we're going to be looking at problem areas that can be solved by linear equations. But before we start, please make sure that if you're new to my channel, you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. So these lessons, they are now a bit more complicated and they require a high degree of thinking a little bit, right? So, but the basic fundamentals are just the same, that when you're solving grid problems by using linear equations, you have to give names to the unknown quantities that you have, right? You can name them using letters. You can call them X, call them Y, Z, any letter that you want. And of course, you need to formulate an equation that you need to use so that you solve for whatever that you're required to do, right? So now, if you attend the first question here, we're told that turn around to a marker and back in 15 minutes. Right, his speed on the way to the marker is 5 meters per second, and his speed on the way back is 4 meters per second. Now, question is find the distance to the marker. So we do the turn around to the marker to a marker and back in 15 minutes. His speed on the way to the marker is 5 meters per second, and his speed on the way back is 4 meters per second. So I have to find the distance to the marker. So what we do is that if we just visualize what's happening here, right, this is number one. So if we say this is the starting point, start, right, and then here we've got the marker B, right. We're told that the total time taken to go from the marker and back is 15 minutes. Then speed on the way is 5 meters per second and speed back is 4 meters per second. So now I have to find the distance to the marker, right, which is from start to marker, right. So, but as you can see, this question is it's got to do with speed, distance, and time. So definitely we need to use the formulas that we know, right? So if we come up with a triangle, which is speed, distance, time, triangle, speed, distance, time, we can see that time is given by distance and speed, right? So if we say let the distance from the distance to the marker be x, right? So we're saying let distance be x meters, right? This would imply that if we are to write the total time in terms of distance and speed, we are saying that from the start to the marker, we've got distance x over speed on the way to the marker is 5 meters per second, then plus from the marker to the start, right, the distance is still unchanged, x over the speed on the way back is 4, and this we're told is equal to 15 minutes. So as you can see, this was in meters per second, this is meters, then meters per second, meters per second. So we need to change that time to seconds, so that will be simply 15 times 60, right? So here, if we get rid of the denominator, we're simply multiplying 4 by 20, so times 20, times 20, then times 20. Right, then we get a 4x plus 5x is equal to 15 times 60 times 20. Let me quickly pass that one out. Times 60 times 20, that will give us 18,000. So this is equal to 18,000. So 9x is equal to 18,000. Then if we divide both sides by 9, x is equal to 2,000 meters. Right. So it means the distance to the marker is 2,000 meters, which you can also write in kilometers is simply 2 kilometers. Right. So this is how we attain the first question. So now moving on to look at how we attain the second question. Now let me erase this. Okay, so for the second question here, we're told that a bus is traveling with 48 passengers. When it arrives at a stop, X passengers get off and 3 get on, right? So this is for the first stop. So from the 48, x passengers get off. So we're saying 48 minus x, that get off, then 3 get on, so plus 3, right? This is now the new number of passengers on the bus. Then we're told that at the next stop, half the passengers get off, right? So half the passengers get off. So this we can actually simplify to 48 minus x, then plus 3. 48 plus 3 is 51. So we can say 51 minus x. This is now the passengers that are on the bus. Then at the next stop, half of the passengers get off. So for the next stop, half the passengers, that's 51 minus x over 2. These get off, then 7 get on, so plus 7. So this is now the new number of passengers on the bus. Then there are now 22 passengers. So this is said to be equal to 22. The now question requires us to find x. So for finding x, we're simply going to solve this equation, yeah? So if you collect like terms, if you take the positive 7 to the right hand side, we've got 51 minus x over 2 is equal to 22 minus 7, which is 15. So if you multiply both sides by 2 to get rid of the denominator, we've got 51 minus x being equal to 30. 15 times 2 is 30. So now if we take this minus x to the right hand side, then we take the 30 to the left hand side. We now have 51 minus 30 being equal to x. So 51 minus 30, we get 21. So x is simply equal to 21. This is how we solve number 2. So now let's look at the last question, which is number 3. So allow me to erase this. Okay, so for number 3, we're told that Mr. Peri left his fortune to his 3 sons, 4 daughters, and his wife, right? Each son received twice as much as each daughter, and his wife received $6,000, right? Which was a quarter of the money. How much did each son receive? So, first of all, we have to figure out the total amount of money that was left behind. So if the wife received $6,000, which was a quarter of the money, we can say let the total be x, right? Such that a quarter of x should give us what the wife got, which is 6,000. So x over 4 being equal to 6,000. X will simply be equal to, you multiply both sides by 4, that's 24,000. So 24,000 was the total amount that was left behind. So if we get the total amount that was left for the sons and the daughters, we're simply saying 24,000, right? 24,000 minus 6,000, which the wife got, and you get $18,000, right? So this was the amount of money that was shared amongst the sons and the daughters. So now we need to formulate an equation using this statement here, right? Each son received twice as much as each daughter, and yeah, we only need that statement. So now if we say let each daughter receive y, let each daughter receive y, right? So if we let each daughter receive y, it means that and there are 4 daughters, right? It means that the 4 daughters will receive 4y, right? $4y, then plus the amount that the 3 sons will receive. We are told that each son receives twice as much, right? Receives twice as much as each daughter. So for each son, we're saying 2 times the y that each daughter gets, right? This is for 1 son, but there are 3 sons then, so we shall multiply this by 3. So the sum of these should give us what was left after the wife got the 6,000. So we shall equate this to 18,000. Then this will be 4y plus 6y is equal to 18,000. right? Then 10y is equal to 18,000. So if we divide both sides by 10, y will simply be equal to $1,800. So it means each daughter received $1,800, but we're asked to calculate how much did each son receive. So if each son receives twice as much as each daughter, 2y will be 2 times 1,800, which is 3,600. So therefore each son receives an amount of $3,600. Okay, so this was simply looking at how we'd solve word problems by linear equations that are a bit more complicated. Please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.